As those who are following the project for some time already know, the Theremin project is reaching its end. We have all the base elements necessary to build a functional instrument, and we just need to put everything together and do the final tuning. However, I'm still working on a final element of this Theremin version 2, a timbre control unit, which is essentially a variable low-pass filter. This element will be presented in a future video on the Theremin. But lately, while working on the timbre control unit, I decided to put together what I already have and see if truly the Theremin is ready to be used. In this video, I will show you how to put all the pieces together, as well as a further minor modification of the audio generator unit needed to make sure that the Theremin will be able to work well in any condition and while the instrument ages. And don't worry, all the changes to the original schematics that I made over time and presented in my videos are all documented and available in the zip file that you can retrieve on my Elenisi.com website. Check its last update timestamp to know if you need to download it again or not. So, without any further ado, let's move to the lab and get started. Here are all the Theremin units that so far I have built, all disposed on the workbench. You can see here on the right the stylus that makes the pitch antenna. On the opposite side there is the volume antenna, which its classical loop shape. Here is the loudspeaker that I made for the lab, and close to it the audio amplifier unit. I did not build yet the preview audio amplifier. I'm still debating if I want to add it to the Theremin or not, and probably I won't, but I will show you how and where to connect it in case you want to use it. The preview amplifier is in fact just a copy of the audio amplifier, it's just that it's used for another scope, bypassing the volume control unit. Next element is the volume control unit, which is located close to the audio amplifier. The power supply is instead on the top area of the workbench toward the center, so it is easier to reach all the units to power them up. And of course, close to it, there is its transformer to lower the voltage coming from the output to a more convenient level. On the lower right, you can see the audio unit with a potentiometer to tune the sensitivity of the pitch antenna, and there is the other potentiometer to control the sensitivity of the volume antenna. The third potentiometer is of course the one used to control the volume of the amplifier. I'm going to start now making all the connections between the various modules. The volume control antenna needs to be connected to the header J3, which brings the antenna directly attached to the resonating tank. The hot wire from the antenna is connected to the pin 1 of J3, which is the lower pin in the schematic but also in the actual PCB. Right now, I'm going to attach the antenna with this cable. Of course, the final connection will be done with a coaxial cable to prevent the cable itself from becoming part of the antenna. The other antenna, the pitch antenna, is connected to the audio generator PCB through the header H3. Pin 1 of the header goes to ground, while pin 2 is the hot wire from the antenna. The orientation of the pins is the same in all schematics and corresponding PCBs, so it is easier to figure out how to connect the various parts together. I will connect next the sensitivity monitor for the volume control unit. Attaching the monitor is very easy, because that is done through a 4-pin header that has both the power supply and the signal attached to it. Now I'm going to connect the volume control unit audio output to the audio amplifier audio input. On the volume control side, this is done through connector J10, the hot pin being pin 1, the one on the top. On the audio amplifier side, the connectors are headers P1 and P2. P1 is the hot wire. Ground pin here is P2, of course, and on the volume control unit is pin 2 of the header J10. For this connection I'm going to use a couple of wires of the kind used for breadboard connections, but with female connectors. All these connections are temporary, of course, because when the Theremin will be assembled in its case, all these wires will be directly soldered to have a good contact on any condition and therefore less chance to get a source of audio noise. Okay, now I will connect the external loudspeaker to the audio amp through the headers P3 and P4. Right now I am using the loudspeaker I made for lab usage. Later on I can either attach the Theremin output to an external amplifier or, for small powers, just any small loudspeaker box like this one. Let's now connect the output of the audio generator, which is on header H2, to the volume control audio input, which is on J7. We always need to be careful when making these connections because it it is very easy to switch the hot wire with the ground. If something like that happens, the power supply will most likely be short-circuited. The power supply will not break because it can handle for a period of time a short circuit without being damaged, thanks to the safety features that the regulators used. However, the circuit that is connected wrongly might be damaged. Actually, it happened to me with the sensitivity monitor when I first tested it, and the op-amp on board died in a cloud of smoke and I had to replace it. So be careful when you do this kind of connections. So now, aware of the possibility that I could have made a mistake in connecting these wires, before connecting the power supply, I decided to test all the connections just to make sure that the ground of each PCB is connected with the ground of the other PCBs and not somewhere else. For this, I'm setting a multimeter to measure resistances, and I go through all the ground pins on the various PCBs to make sure I measure a resistance of 0 ohms between each 2 points. All of this very carefully, of course. Now that I made sure that all the connections are fine, I can start connecting the power supply to the various items, beginning with the audio amplifier. Here I have a header P5 for the positive and P6 for ground. Remember that the audio amplifier does not use a dual voltage, only the positive with respect to ground, so I only need 2 wires. Let's now turn on just the amplifier to check if it is connected correctly, and judging by the noise it looks like it is. Let's now connect the volume control, which has the power supply on the J1 header. We need 3 wires in this case, since the volume control unit has a dual power supply of plus and minus 12 volts. Let's now try again with the power supply on to see if anything starts burning. Well, it looks like it is not possible to adjust the sensitivity control though. Well, at this point I will need to make some checks. Hang on for a moment. Okay, here is what I had to do before moving on. First, using my 3D printer, I built a support to hold in place the potentiometers, so I didn't have to touch their body while tuning them. This holder also helps reduce the clutter on the workbench and can be reused for other projects in the future, a useful addition for the lab tools. Second, I realized that the sensitivity potentiometer for the audio generator, although working fine, was doing all its job just with subtle movement of the knob, which defeats the purpose of having a multi-turn potentiometer for an easier tuning. And so I had to go back to the drawing board and do some extra calculations to extend the maneuverability of the potentiometer. I ended up having to make just one small change on the value of resistor R1, which I changed from 470 ohm to 560. Now it is much easier to tune the sensitivity of the pitch antenna. Okay, here is the support for the potentiometers. It's very simple but effective, as you can see. This support will come in handy in the future to organize potentiometers in future prototypes. The knob on the left controls the volume of the audio amplifier, the one in the center controls the sensitivity of the volume control unit antenna, and the one on the right controls the sensitivity of the audio generator antenna. I've also replaced the cable for the volume potentiometer, which is now a coaxial cable. The cables of the other 2 potentiometers instead were not changed. The volume potentiometer coaxial cable is now soldered directly to the PCB of the amplifier, so we won't get any more of those bad noises we heard earlier. So now that everything is set better on the workbench, the sensitivity monitor is working correctly, and you can now also see the audio signal coming out of the audio generator, which is now also powered. Note how I can silence the sound by moving my hand in front of the volume antenna. Now let's make some music. Well, Okay, I think I have to do a lot of practice before being able to play decently the theremin, but that is for another time once I complete the project and have the instrument assembled in its own case. In the meantime, this was kind of a proof of concept in being able to control the volume of the sound with a second antenna and, therefore, have a better dynamic of the sound. The one thing that I still want to add, although not necessary, is a low-pass filter. For one, it will help to have a cleaner sine wave in the audio range, which will greatly improve the timbre of the theremin, and also it could also allow me to change the timbre at will, assuming that I can remove the extra harmonics of the sound waves in a controlled manner. This, of course, will need some experimentation and will be the subject for the next video of the theremin. Don't forget to download the new zip archive containing the correction for the audio generator from the ilanisi.com website. And, while waiting for the next video, I wish you my usual happy experiments.